So let us continue our discussion on the PWM workshop. So here in the previous workshop we have talked about the duty cycle definition, which is very important from a microcontroller perspective, or from a programmer of a microcontroller who need to generate a variable output voltage. So just reiterating again, when a T on is 0 and T off is equal to 1, that means T off means low. So that means when you apply a low here, the output would be, because when it is low and it is a N channel, so this would be off, so the output will be high. So the scenarios described here would be for a P channel. So here I am talking about N channel in this circuitry. And again, if the T on is 1 and T off is 0, that means on is high and T off is always 0. That means a high pulse, high signal. When a high signal is provided, the FET would be on for a N channel FET, and as it is on, so this would be 0. So that means the output will be 0. And if that is not the scenario and T on and T off are controlled through the duty cycle from a microcontroller, the output voltage will be varying based on the signal that you are providing from the microcontroller. So after understanding all these scenarios, the major thing that we have to remember from the microcontroller perspective in a PWM scenario is that there are two parameters, which is one is frequency and second one is cycle. So these two are the important parameters, and so when you understand that, anyway, we generally people know that frequency is always inverse of time period. Time period is nothing but T on plus T off. So the frequency is generally, when we use, is always a fixed frequency in a PWM interface, but there are scenarios where you use variable frequency as well. And so when we talk about variable frequency and duty cycle terminologies, different scenarios can occur while controlling the load using a PWM scenario. You can provide a fixed frequency and a variable duty cycle, and then variable frequency and a fixed duty cycle, fixed frequency, fixed duty cycle, variable frequency and variable duty cycle. These are the different scenarios. So the last one, variable frequency, variable duty cycle, is very complex sometimes. So there are very rare scenarios that people use them. And as we are continuing from a microcontroller's perspective, what it means to a PWM interface, one thing is that we understood that frequency and duty cycle is what is important from a PWM generation perspective. Now, to generate this, what need to be done inside a microcontroller? So to generate the frequency and required duty cycle, the timer inside the microcontroller is used. So if you have a PWM pin from a microcontroller, generally there would be a timer associated with it, or you can associate a timer in your program, and based on the timing that is set, you can generate the required frequency and duty cycle. So as we know internally, okay, anyway, we are always talking about basics here. So internally in the microcontrollers we have something called registers. We will talk about in the programming. So when you load these registers with specific values, the PWM will be generated from the output of the microcontroller. Now as we talked about all these scenarios, one thing, when we go back, so if you are giving a variable duty cycle fixed frequency signal to the gate of this MOSFET, the output voltage will be varying continuously based on the duty cycle. That means you are generating a analog voltage at the output using a digital input. So what we are talking here is you are controlling a analog circuitry using a PWM signal. So that, and in a real world scenario, one example could be a motor control, and second one could be a solenoid valve control, or a loudspeaker control. So these are all the different application scenarios that comes up when you talk about the PWM. Now one thing that we have to remember is, whatever we are doing, it's all digital in a PWM and there is no analog involved. So we'll talk further in next